Ladies and gentlemen, boys and girls, children of all ages. We're going to review a couple problems here. You have a review sheet for our fraction test that we're taking on Friday. I had an email saying they had a problem on question number 4. So I thought we'd work through question number 4. And also question number 10, I believe, yes. Question number 10. So let's look first at question number 4. As I have it on the board, you can read along. At Cecil's Pizza Shop, each slice is 1/6 of a pizza. If 5 friends each ate 1 slice of a pizza, which expression shows how much of the whole pizza they ate? Now, it's called an expression because it's the problem, the algorithm, without an equal sign. Without an equal sign. So first, we need to know that each slice is 1/6. We need to know 5 friends each ate 1 slice. So if I had, as my friends, if I had Morgan ate 1 slice. So she's eaten that much. If I had Mason eats 1 slice. Now that much of the pizza is gone. If I then had Sahana, she ate 1 slice. That much of the pizza is gone. And ideally, those slices would all be the same size. Jason, 1 slice would be gone. Now that's 4 friends. And Kinley, 1 slice would be gone. Now our question says, how much of the whole pizza they ate?
5/6.
They ate 5/6, right? 5/6 eaten. Now all we have to do is look at these and see which one is going to give us 5/6. See which one's going to give us 5/6. Now, before we do that, in my 77 years of teaching experience, what I have found with problems that give you the expression or the equation is students don't want to do any work. They just want to look and see if they can figure things out. So now we know what our answer needs to be. We know that 5/6 of the pizza was eaten. So we just have to figure out which one of these gives us the answer of 5/6. So look at my answer choices. Colin, are there any answer choices you would like to eliminate immediately?
The 1/6 plus 5 one.
1/6 plus 5. Because what would be the sum of that?
5 and 1/6.
5 and 1/6. We want our answer to be 5/6. That would mean that they ate 5 whole pizzas and 1/6 of a slice of pizza. Sanaya, do you have... I know, I was talking to Sanaya. Sanaya, do you have one you would like to eliminate?
B.
B. Why?
Because it would be 6 and 5/6.
It would be 6 and 5/6. It would be 6 and 5/6. Joshua, do you have one you would like to eliminate and why?
A, because it already has 5/6, but then they're still adding on to it.
Okay? It already has 5/6, and we're making that bigger. What's multiplication is
Repeated addition.
repeated addition. Multiplication is repeated addition. So this problem would be like 5/6 plus 5/6 plus 5/6 plus 5/6 plus 5/6 plus 5/6. And that's definitely not going to get us an answer of 5/6. So Chloe, what answer do you think is correct? D. Because then we have 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6. And that would be 5/6. So the correct answer is most definitely D. The correct answer for that one is most definitely D. So when you get to that question on tomorrow's test, just think. Go back in your mind and say, oh yes, they ate 5/6 of the pizza. Oh yes, the only answer that would give us an answer of 5/6 would be D.
But it's not gonna.
All right, so that was one of the questions on the test for tomorrow that I have emailed home to your parents, and if they really, really, really like you, they have probably given it to you and worked through some of the problems with you.
My parents really like me.
If they really like you.
They like me.
All right, so now let's look at the review sheet. We have the problem 8/10. Subtract 2/4. Now on the review sheet, this problem is written horizontally. I may have told you before, in fact I know I have told you before, when adding and subtracting fractions, you want to write them vertically. You want to write them vertically. That is an excellent question, Maribel. We want to write them vertically because we have to change these so that they have a common denominator, the same denominator, without changing the value. Morgan. 40. Okay? 40. Let's check. Okay? We're going to find the least common denominator. And we're checking because I want everybody to see the steps. All right, so we're taking our denominator of 10 and 4, and we're basically making a multiplication choice or chart for those two numbers, which on the test you can look at your multiplication chart. But I always like to start with the smaller one and list 3 or 4 of the smaller one, and then if they're not the same, list 3 or 4 of the bigger one, and kind of go back that way. So we'll start with the smaller one, 4, 8, 12, 16, 20. Let's look at the larger one, 10, 20, 30, 20 they have in common. 40 they also have in common. So you're not necessarily wrong. But it's going to save us. We're going to definitely have to simplify if we go with 40, and I don't know if we're going to have to simplify when we get to 20. Jason.
Like, I did the problem a different way. Like, I made 2/4 into 5/10, so 2/4 is 1/2. And that's what
Brilliant. Brilliant. Now, this is a half. So what Jason did is instead of writing a half as 2/4, he wrote a half as 5/10. Because 5 is half of 10, just like 2 is half of 4. So that's the same value. It'd be like 50%. If you got 2 out of the 4 questions right on a test, you'd get a 50%. If you got 5 out of the 10 questions right on a test, you would get 50%.
3/10.
So now we're going to change, and I'm going to use the 20 just because I want you to see the whole process. We need to change these fractions without changing the value. Now what I saw and what I heard when you're talking about it is you just change the denominator, some of you, without changing the numerator. We can't do that. That changes the value of it. We found our least common denominator, which equals 20. So I'm going to change both of these fractions so that they have a denominator of 20 without changing the value. Without changing the value. So Cain, 10 times what equals 20? 2. Awesome. And since I need this fraction to equal 1, both my numerator and denominator have to be the same, or my fraction's not going to equal 1. This is where we've learned how to multiply fractions. So there was someone come up to me, and I don't remember who, that said, I don't know how to multiply fractions. Well, multiplying fractions is straight across. We did 10 times 2 is 20. 8 times 2 is 16. So that's how you multiply fractions. Numerator times numerator, denominator times denominator. Now, we have 2/4, and we need to change that to something over 20. Drew, 4 times what equals 20?
4 times 5.
4 times 5. And since I have to multiply straight across, 4 times 5 equals 20. That's how I know my 5 is there. I need my fraction to equal 1. So 2 times 5 equals 10. Because multiplying fractions goes straight across. So now you know how to multiply fractions, and we know how to subtract here in one moment. You're going to want to pay special attention to the sign so that you realize it is a multiplication sign. That was crazy. That's not a multiplication sign, that's a subtraction sign. Golly gee willikers. Alright, so we have 16/20 subtract 10/20. Now, as we know, when we're subtracting, the denominator stays the same. Because just like when we added 1/5 of a piece of pizza plus 1/5 of a piece of pizza, that was 2/5. We don't mess with the denominator when we're adding or subtracting. Now, we did when we were multiplying. And we will when we're dividing. And then we just do whatever it says to do to the numerators. So, Jared, 16 subtract 10 is? 6. 6/20. Now, a couple of my friends here told me that the answer was 3/10.
Yes.
And they're correct. And they're correct. Because 6/20 can be simplified.
Yeah.
To simplify, if you don't know, I know you know what the greatest common factor is. But I want to show how to find the greatest common factor so that you can know how to do it when you can't necessarily figure out what the greatest common factor is. I'm just saying. I take my numerator of 6 and my denominator of 20, and I'm going to list all of the factors of each. So, Natalie, what are my factor pairs for 6?
6 and 1.
Okay, 6 and 1.
3 and 2.
3 and 2. And what else? Nothing else. Good. My factor pairs for 20, Izzy?
There's 1 times 20.
Awesome. 1 times 20.
4 times 5.
4 times 5.
5 times 4.
5 times 4.
10 times 2.
2 times 10. Awesome. And that is all of them. Okay, we know if we use our divisibility rules, which are in your journal, I know it's divisible by 20 because it ends in a 0. I know it's divisible by 5 because it ends in a 0. I know it's divisible by 10 because it ends in a 0. Those divisibility rules are helpful. So now we look for the greatest one they have in common, and that is what, Colin?
That is 2.
2. Now, once I know my greatest common factor equals 2, I divide both my numerator and denominator by 2. Both my numerator and denominator divided by 2. So, JJ, 6 divided by 2 equals? 3. And we could always look over here. 6 divided by 2 equals 3. JJ, 20 divided by 2 equals? 10. Good. 20 divided by 2 equals 10. So writing all this stuff down helps us because we could just look back at that and makes us happy. So even when Jason did it his way and changed 2/4 to 5/10, he got 3/10. When we did it and changed the denominator to 20, we got 3/10. If we change the denominator to 40, like Morgan did, which is fine, you can just multiply the two denominators together and get 40, we're still going to get 3/10 when we simplify. All right, so that's one of the adding and subtracting problems. I want to show a couple of the division. And I'm going to do different problems off this review in each of the classes. And I'll do a different problem from the test in each class too. So, I make these videos and I want to be rich and famous, but they will help you if you watch them.
It's not expensive.
Yes, I would like a sponsor.
Yes.
So let's take first, we have the problem 1/3 divided by 4. That is on the back. One of the things we know when we're dividing by a unit fraction, which is a fraction that has a denominator of 1, when we have that, if the unit fraction is the one being divided, is my dividend, then my answer is going to be a fraction. If the whole number is what's being divided, my answer is going to be a whole number. At least for what we've learned thus far. It'll be different as you move in life, but with a unit fraction, that's how it works. With a unit fraction, that's how it works. They gave us the picture that looks like this. Your notes on 275 help you also, because if you have one shape, that's usually going to mean the unit fractions first. And we do what it says. We divide first into thirds. And then we're going to take our one drawing, our dividing it into thirds, and we're going to take that and divide it into fourths. And what we're looking at is just one slice, one piece of that square. One piece of that square. Since that's one piece of that square, that tells us my numerator is 1. Because all I'm looking for is this one piece. And then I need to figure out how many total pieces there are. So Ian, how many total pieces are there? 12. 1/3 divided by 4 equals 1/12. 1/3 divided by 4 equals 1/12. Just remember, if the unit fraction, and Kinley, how do I know if this is a unit fraction? Because the numerator is 1. If the numerator is 1, that's what's called. It's called a unit fraction. Because you're only trying to find one of something. Okay? So if it's a unit fraction, I'm going to get an answer with a unit fraction. If the unit fraction is what's being divided. And it will usually come with just one whole. This whole square was one whole. The whole thing was one whole. Now let's look at one. Let's look at the last one on there, which is 4 divided by 1/2. 4 divided by 1/2. Now, if you were gone yesterday, this is what we covered yesterday. So if you were gone yesterday, pay real particular attention to this specific problem. If you struggled yesterday on 279, 280, pay real close particular attention to this problem. The drawing they give you has how many holes in it? 4. It has 4 holes in it. This is 1 hole. I think it goes like that, right?
Yeah.
Okay. This is 1 hole. This is 1 hole. And this is 1 hole. And ideally these, like I said, would all be the same size, but for the purposes of the video, it makes it easier. So when dividing, if the whole number's first, Mason, make sure you watch. This is what we did yesterday. When dividing a whole number in a fraction, if the whole number's first, 4 holes divided by 1/2. So we have 1, 2, 3, 4 holes. If it's first, that's going to tell you how many holes you have. 4 holes divided by 1/2. Now you take those 4 holes and you figure out what 1/2 of that is. So I'm just drawing my line. And what this is asking are how many halves are in 4 holes. And then it's just a matter of counting. 1, 2, 3, 4, 5, 6, 7, 8. 4 holes divided by 1/2 equals 8. All I have to do is count how many halves are in 4 holes. How many halves are in 4 holes? Sahana? 8. There are 8 halves in 4 holes. Question, Joshua? No. 8 halves in 4 holes. If you remember, if the whole number's first, your answer's a whole number. If your unit fraction is first, your answer's a unit fraction. But it works only with a unit fraction. Works that way only with a unit fraction. When you have other fractions, it will be different. If the whole number's first, it's going to give you that many holes. So if you see a problem and it says, here's your picture, which expression does it represent? And it gives you that many holes. If it has more than 1 holes and it's a division problem, that means your whole number is going to go first, because there are some problems on that tomorrow. Oh, let's see if there's another one that looks like I could do. I think we're going to leave it at that. Next class, I'll go over a couple more problems. One from the test, and then some from this. Make sure on the back of that review sheet, you write down the table of contents. You don't have to write the date, just what you have and in the order you have it. Use this to study at home. Use the test that I emailed at home to study. I mean, some people are going to be smart and just bring it in completed. I'm cool with that. I'm cool with that. You'll turn in the review sheet when you come into class tomorrow. Questions? Alize?
So we could print out the test at home and do it.
Yep, you can print out the test at home and do it and turn it in. I'm fine with that. Make sure you put your name on this review sheet, because you're going to turn it in tomorrow. And one of the things that makes me crazier is when I get papers with no names on them. And then I say, hey, Kinley, I'm missing your assignment. She goes, I turned it in. I know you lost it. And then I give her the stack of papers. This is what's been turned in. And she goes, oh, this one with no name's mine. After she blames me, makes me cry. I lay in bed at night going, why does Kinley hate me? Boom, shakalaka, peace out. God bless, love you. Do something kind. Sonic, sponsor me. Subscribe.